All right, hello students. These are the two problems that I would have done with you guys in class if I were in school. So I'd like you to copy down these problems and their work on a piece of paper that you're going to turn in as part of your classwork, and then you'll see a posted worksheet. On that posted worksheet, I'd like you to select any 8 problems there. So you're doing a total of 10 problems in class and then finish them for homework, and that will be collected tomorrow. Okay, so if you'd like to try example 1 and example 2 on your own, pause the video. Otherwise, I'm going to get started. So as I look at example 1, I think I might just look at it and do a form of substitution. So y is sort of already solved for in this equation. So I'm going to go ahead and write the top equation and substitute in what y is into it. So x plus y is equal to 1. That's my top equation. I'm going to replace y with x squared plus 5. All right, what I have left is quadratic. So I'm actually going to set this equal to 0 by subtracting 1 on each side. And it looks like I get the equation. I'm going to rewrite it with x squared plus x and plus 4. So as I look at that, that is something that if I try to factors of 4 are 2 and 2 and 1 and 4, and none of them add up to be 1. So this is a situation where I'd kind of go straight to the quadratic formula. All right. So x is equal to negative b, negative 1 plus or minus the square root of b squared 1 squared minus 4 times our a value 1 times our c value 4 all over 2 times our a value, which is 1. So I don't have to go too far into this, and hopefully you realize we're going to get negative 1 plus or minus. Let's focus inside that square root. It's going to be 1 minus 4 times 1 times 4 is 16. That's going to be negative 15. And what I have here are imaginary solutions added with real numbers. So this is a complex solution, complex solutions. In other words, when are these two curves going to intersect? They are not. The correct answer is no solution. All right. So this is the equation of a parabola. This is the equation of a line. And that one we can kind of do really, really quickly in our brains. The parabola has a vertex at 5. And if I solve for y here, y equals negative x plus 1. There's a y-intercept of 1 with a slope of negative 1. That line would kind of look like that. And those two curves, well, the parabola and that line would never intersect. No solution. All right. Very good. Let's take a look at the second problem here. Second problem, yeah, I could use substitution, but it looks like it's all set up for elimination. So I'm actually going to eliminate the y's, or excuse me, the y squareds, and I'm going to add these two equations together. So if I add them together, I'm going to get 3x squared is equal to 12. At that point, the y's cancel out when I add them. At that point, I'm going to solve for x. So divide by 3 on each side, get x squared is equal to 4. And then I can square root each side. And let's not forget that when you square root both sides, you get not just positive 2, but also negative 2. So we have two solutions here. I guess I would want to plug them back into the second equation there. So I'm going to plug them into x squared plus y squared equals 7. Now I'm supposed to plug both of them in. So first I'll plug in 2. That's going to give me 4 plus y squared equals 7. So y squared equals, it looks like 3. So that's going to give me 2 solutions, plus or minus the square root of 3, which means when I plug in 2, I get 2 answers, 2 comma the square root of 3 and 2 comma the negative square root of 3. But I also need to plug in the other 2, which was negative 2. And obviously, if I plug in negative 2, I'm getting essentially the same work because I get 4 again. And when I solve for y squared, I'm getting 3 again. So when I solve for y, again, I'm getting plus or minus 3, excuse me, root 3. So it turns out that this system has actually got 4 solutions. And I'm going to show you what that looks like. So we also have negative 2 root 3 and negative 2 negative root 3. So 4 points of intersection. So one of these is a circle, this one right here. The other one is a shape I mentioned the other day called a hyperbola. And let's see what it looks like on Desmos. Boom. So here's the equation of our circle. And here's the equation of our hyperbola. So hyperbola is this kind of crazy curve. Usually graphs as 2 curves. And you can see we have 4 points of intersection. So ladies and gentlemen, do your work on a separate piece of paper that can be collected. And you should see the worksheet posted. Again, you're going to select 8 out of the 18 questions, 8 out of the first 18 questions to do. All right. Have a good day. See you tomorrow. Bye.